Hello and Namaste. In continuation with the Z transform, we have started with the series of the problems. So this is also one of the set of problems we have taken up for the today's session. Now find the Z transform of sine square n pi by 4. Now how to deal with the different trigonometric function that we are going to deal with now. Function is sine square n pi by 4, which is same as, so it's like a square theta. So sine square theta is nothing but 1 minus cos of theta by 2 by 2. So this is what we have. We do have it as a double angle or a half angle formula. So it's nothing but 1 by 2, 1 minus cos of n pi by 2. Now cos of n theta is equals to z into z minus cos of theta upon z square minus 2z cos of theta plus 1, if this is the condition. Now this is one of the standard formula which we have already seen with the previous session. Please do follow the previous one. Taking the z transform of this particular function, will be taking it as z transform of half minus 1 by 2 times z transform of cos of n pi by 2. Now that is nothing but z transform of half is nothing but z upon 2 times z minus 1, or otherwise you can say that it's nothing but 1 by 2 times z transform of 1, and we know that z transform of 1 is nothing but z upon z minus 1 minus 1 by 2 times whatever the function we have taken it. So this is nothing but n theta, we have got n pi by 2. So we have just have it here, the value of theta is equals to pi by 2. So we have taken up pi by 2, theta is equals to pi by 2. Now cos of pi by 2 and cos of pi by 2 from the numerator denominator will move to 0. This will also move to 0 and will remain here with the answer as 1 by 2 z upon z minus 1 minus, this will be the, as this is moving to 0, it's just a z square in the numerator. Denominator we will have it as z square plus 1, because cos of theta, cos of pi by 2 is again is equals to 0. So this is the z transform of sine square n pi by 4. If we have got the function sine cube of n pi by 6, then it's a cubical formula or sine cube of theta, that will gives us 3 by 4 times sine n pi by 6 minus 1 by 4 times sine n pi by 4. So this is what we have used, the trigonometric function of sine cube theta is equals to 1 by 3 times sine theta minus, sorry, it's 3 by 4 times sine theta minus 1 by 4 times sine 3 theta. This is what we have used is here the formulas. Then that is applying the z transform of this particular function, will be having it as, according to the linearity property, we will be following this up as this one. Again this z transform of sine of n theta is z into sine theta upon z square minus 2z cos of theta plus 1. Again the theta, the value of theta in the first bracket is pi by 6, second bracket it is pi by 2. Now if you have this theta is pi by 6 over here, so we'll be having the formulas 3 by 4 z into sine of pi by 6 upon z square minus 2z cos of pi by 6 plus 1 minus 1 by 4 into z into sine pi by 2 upon z square minus 2z cos of pi by 2 plus 1. This is what we have got it just by putting the values of sine pi by 6, cos pi by 6, sine pi by 2 and cos pi by 2. We'll be having this. So this is just a simple substitution which we have taken up for the sine pi by 6, cos pi by 6, sine pi by 2 and cos pi by 2. So cos pi by 2 is moving to 0. Similarly sine pi by 2 is moving to 1, and this sine pi by 6 and cos pi by 6 will be taking the respective values and will be having this particular value over here. Now find the z transform of cos of n pi by 2 plus pi by 4. Now here we will be using the expansion of cos of a plus b, which is nothing but cos a into cos b minus sin a into sin b. Where is this particular value is a, and this is nothing but the b, what we have taken it here. Taking the z transform of both the sides, so now cos of pi by 4 is nothing but 1 upon square root of 2. Similarly sin pi by 4 is 1 upon square root of 2, and hence we'll be having this as cos n pi by 2 minus sin n pi by 2 into this 1 upon square root of 2. So 1 upon square root of 2 is out, and the z transform of cos of n pi by 2 minus z transform of sin n pi by 2, again Z transform of cos n pi by 2 is nothing but z square upon z square plus 1, and sin Z transform of sin n pi by 2 is nothing but z upon z square plus 1. We have already taken up this particular formulae in before previous sessions. Please do follow the previous one. Just by taking those values over here, we'll be getting the value or the Z transform of the function cos of n pi by 2 plus pi by 4 as 1 upon square root of 2 into z minus 1 upon z square plus 1 as the answer for this particular function. I hope you are getting this different questions which I'm trying to deal with the different questions in the session so that you can solve any type of question at any time. I hope. Thank you. Happy learning.